Welcome back to Chem Quiz online class. Let's look at what the reactions of the alkenes. And this is one important aspect of organic chemistry that you can never escape in your exam. And it's one of the most interesting parts of what reactions of the organic compound. So please pay close attention here because this is going to be a fundamental class when it comes to the reactions. So in this video here, we're going to look at what the typical reactions. Typical reactions in which what alkenes undergo. They want to look at some various type of reaction in which what alkenes undergo, like the hydrogenation, the halogenation, the hydrogenation, the hydration, and some other what reactions. So you want to what pay close attention. So this is going to be the first part of the reactions of what of the alkenes. So the second part is going to come up. Make sure you don't miss that. Which I want to talk about the oxidation aspect. So now let's look at what the foundation, like the fundamentals. So what you want to understand here is that alkenes is an unsaturated compound, organic compound. It's called unsaturated hydrocarbon, unsaturated. Now, for an organic compound to become unsaturated, then now it must have for a compound to become unsaturated, then it must have a pi bond. So alkenes are double bonds. Okay, double bond. Now it's very important to know how to name alkenes, the nomenclature of the organic compound. I've done a complete video. I have a playlist when it comes to what nomenclature of the organic compound. It's very important. So all alkenes and alkynes are what are unsaturated hydrocarbon. Now all unsaturated hydrocarbon undergo what addition reaction. So alkenes, the typical reaction in which alkenes undergo is called addition reaction. Addition reaction, very important. Now, all alkenes are nucleophile. Do you understand? What you want to understand here is that all alkenes are what nucleophile. As a matter of fact, all unsaturated compounds are what nucleophile. Now, they are what nucleophile. Nucleophiles. Right there. What is nucleophile? Nucleophile, there are electron-rich atoms. Electrons rich atoms. Okay, electron rich molecules. Electron rich what molecules or atoms. Do you understand? So now when I see a double bond or a triple bond, it's called nucleophile. Do you understand? And all unsaturated compound undergo what addition reaction. So the question that be, what are you adding? If alkene, like this one here, CH2, double bond CH2, is what nucleophile. What are you going to add? Now you add electrophile to it. Now for a reaction to occur, you must have electron-rich atom and electron-deficient atom. Do you understand? So like what I say here is that the electron-rich atoms are what nucleophile. Now, while the electron deficient atoms are called electrophile. So here we have nucleophile. We also have called electrophiles. Right there. Electrophiles are electron deficient atom or electron seeking atom. Do you understand? So those species that seek electron in a chemical reaction or in an organic reaction is called what? Electrophiles. Do you understand? We are going to look at them very soon. But understand that for a reaction to occur, you must have what? A nucleophile and electrophile. Nucleophile is what donate the electron. Electrophile is what accept what the electron. Do you understand? So one thing you want to understand here is that since alkenes undergo what addition reaction, what you want to know is that you add electrophile to the alkenes. So all alkenes need what electrophile for the reaction to what to occur. The reaction to occur. Right there. So the typical reactions in which what alkenes undergo is not just addition reaction. It's called electrophilic addition reaction. Electrophilic addition reaction. You see this in the exam. So that is, you are adding electrophiles, you are adding what electrophiles to the alkenes to get what the product. Do you get that? So we are going to look at what the various type of addition reaction. So we have to talk about the various type of what of addition reaction. So addition reaction is what is addition of what molecule or group to an unsaturated compound to produce what is saturated compound. Then you are adding what groups or molecule to what to these double bonds to break the pi bond to form what a single bond. So in say that in addition reaction you convert what unsaturated compounds to what saturated compound. Do you get that? And the first reaction we want to look at is called hydrogenation. Hydrogenation. Hi there. Hydrogenation. Now, what do you understand by hydrogenation? Hydrogenation is the addition of what? Hydrogen. When you add hydrogen to alkene, it's called hydrogenation. Do you understand? So hydrogenation is what is the addition of what hydrogen to what to the what alkene in the presence of what metallic what catalyst. And the metallic catalyst can either be what lithium, it can either be platinum, nickel, or palladium catalyst. Do you understand? So, if for example here, there is add what hydrogen CH2 in the prayer of what now the catalyst needed is that what nickel, platinum, or palladium. Do you understand? These are three possible catalysts you need for the what reaction. A good example here we have CH2 double bond CH2 plus what H2. You need any of these catalysts to power the reaction. So you need what nickel. Okay. So when this reaction occur here, remember here we have a single bond and what a double bond here, right? So we have what a sigma bond and a pi bond. Now this additional reaction takes place to break what the pi bonds. Just so here we have two hydrogens. So one will be added here and one will be added here, right? To break what the pi bond. So when you add one hydrogen here, you have what CH3, right? Then you have what CH3. It means that this double bond are converted to what to a single bond. That is the unsaturation here are converted to what to saturation. Do you understand? This is called the addition reaction called hydrogenation. Addition of what hydrogen. Addition of what hydrogen to what to the alkene to form what alkenes. So here we have 18. And here we have 18. Just here we have what the hydrogen, here we have what the catalyst. So you can see how easy it is. If for example here we have another one like this plus H2 in the presence of what platinum. Right there. So one hydrogen be added here, one hydrogen be added here. So the double bond will disappear. So I'll have this one. It's okay. So they call cyclo what pentene. And here we have cyclo what pentene. So you are adding hydrogen to these two carbon here to break the double bond to form saturation here. Do you understand? So this is called hydrogenation. Hydrogenation is not that too difficult. You understand? You are just adding what hydrogen to the what to the double bond to form what a single bond. Do you understand? That is it about what hydrogenation. You get. So let's look at what the next one. Now, halogenation means what? Addition of what? Halogens. When adding halogens to what? To alkenes is called halogenation. Now the product I want to get is called dihaloalkenes. So in the sense that you are adding what? Halogens. I get. Now there is no catalyst here. So the reaction can proceed like that. So if I don't here we have CH2 double bond CH2 and here we have X2. Now this X can either be a chlorine or a bromine. The only thing you need is called the what as the what organic what solvent. You only need organic solvents. Do you understand? This organic solvent is ether, so it does not take part in the reaction. It just dissolve it. Use what it occur. So now what happens here? Just like the way we added hydrogen, you want to add X here. You want to add X here. So it's going to be CH2. Here we have X, here we have what X. So these are what the two halogens. So if I have something like CH2 double bond CH2 plus what BRO2. Now what will be the product? Here we can say ether. At times you can leave this one here because this is not what catalyst. So what happen here? here I have this added here and added here. So here I have CH2 B out CH2 B what Can you see that? So what is the name? Going to be 1,2-dibromoethane. So here we have 1,2-dibromoethane. This is that. You can see how easy it is. So if I should drop one down here like this, probably you have something like this. CH3, CH2, C double bond, CH2 plus what? Cl2. Here we have ether. What happened here? Now, your main concern is these two chlorine won't be added here, won't be added here. Do you understand? So to break what the pi bond. So here and I have CH3, CH2, here we have CH, CH2, here I have what? Cl, Cl. Do you understand? So what will be the name of this compound? So it will be 1,2 dichloro. 1, 2, 3, 4. Butane. 1,2-dichloro what? Butane. That is name of what? Of the product. Do you understand? Now, another thing you want to understand is that for every product you give, you must give the name, the impact name of that product. If not, you're not going to get the answer. So you can see how easy it is to what? Halogenation. Halogenation is not that too difficult. Do you understand? Not that too difficult. Now, the next one I want to look at is called hydrogenation. This is the addition of what? Halo acid. Like here we have HCl or what? HB what? Called halo what acid. Now, in this reaction here, you have to use a rule called the Markovnikov rule. Unlike H2 and what B arrow 2 or C. Now you can see that you are adding the same, you are adding two hydrogen, here you add what two bromine, here you add what two what chlorine, right? So it does not actually matter where you add them because they are the same. But what happens when you're adding HB arrow or HCl? Do you see that? So there's you're adding two different things. Here you're adding what two hydrogen. Here you add what two bromine. Here you add what two what chlorine, right? But here you add what an hydrogen and a bromine, or an hydrogen and what and a chlorine. Do you understand? So this way, I want to use what's called the Markovnikov addition or the Markovnikov rule. So in hydrogenation, you use a rule called Markovnikov rule. In when you are what doing the addition reaction, you use what we call Markovnikov rule. And in Markovnikov rule, hydrogen is always added to the carbon atom with more hydrogen atom. So you say that when you're adding either HBr or HCl, what will happen here? The hydrogen is always added to the carbon atom with more hydrogen. While the halogens is always added to the carbon atom with what less hydrogen. That's what's called Markovnikov addition. So if for example, here I have CH2 double bond CH2 and I'm adding what HB what R. Now what will be the product? Please look up. Now, although all this reaction I'm doing here, there are mechanisms, but in this video, I'm not teaching what the mechanism is, the step by step, because it's not important. They will only ask you what's the product of the reaction. Do you get that? Now, remember, here we have HBr. Do you understand? So, therefore, let's check if the two carbon atoms are the same. So, how do you know if the two carbon atoms are the same? If they have the same mass of hydrogen, so they are the same. So here we have this carbon atom is carrying what two hydrogen. This carbon atom is carrying what two hydrogen. So they are equal mass of hydrogen, right? So there is my hydrogen can be added anywhere. I can either add my hydrogen here or I can add my hydrogen here. There is no problem with that. Do you understand? There is no what problem with that. This is what is called symmetrical what alkene. Symmetrical alkene. Now the main reason why it's called symmetrical alkene. Now, the main reason why it's called symmetrical because the two carbon atoms have equal numbers of what hydrogen. Do you understand? Or they carry the same numbers of hydrogen. So in symmetrical alkenes, The Markov rule does not actually play here because the two carbon atom carry the same numbers of hydrogen. So you can add hydrogen here. So you can add hydrogen here, and you can add what bromine here, or you can add hydrogen here or what bromine here. Depending on the one you choose, they are going to be the same. So if I decide to add hydrogen here, so what am I going to get? I'm going to get CH3. It's okay. Now remember, as I'm adding, I'm breaking what the pi bond, right? Level what with a single bond. So I'm going to add Br here. So you have CH2 B what arrow. Do you see that? So the name of this thing here, the name of this product here is going to be bromoethane. Bromo bromoethane. Or somebody will say one bromoethane. Whichever way you want to put it here, you understand. But the most accurate one is this one here. So you can say how easy it is. If I should look at this other one here, CH3, here we have CH3. Now, plus what? H, B, what? Arrow. What will be the product? Right there, what will be the product? Now, the product here, these two carbon atoms have equal numbers of what? Hydrogen, right? So now your hydrogen will be here, B and what will be here. Do you understand? So if I should add hydrogen here, yeah, I'm going to have CH3, CH2, CH, here we have B and CH3. What will happen? So the product is going to be two bromobutane. Two what? Bromo what? Butane. Two bromobutane. You can see that two of them are called symmetrical alkene. Now, why are they called symmetrical alkene? They are called symmetrical alkene because the two carbon atoms that carry double bond have equal numbers of what? Hydrogen. Do you understand? So yeah, mechanical fluid will not actually not take place here because the two carbon atoms have equal numbers of what? Hydrogen. This carbon atom have two. This carbon atom have two. Fine. This carbon atom have one. So have one. Right? So what about if they don't have equal numbers of hydrogen? Let me show you something. So if for example here we have CH3, CH double bond CH2, then you have plus HCl. What will happen here? That this way you're not going to use the Markovnikov rule. Do you understand? Because here, if I have carbon A and here carbon B, what will happen here? Carbon A is having two hydrogen. Carbon B is having what? One hydrogen. So I can just add the hydrogen anywhere. You get what I'm going to do here is that hydrogen will be added here and Cl will be added here. Now there's a mechanism for this reaction. There's a mechanism for this reaction, step by step, in which what the reaction takes place. Now, but for the sake of this video, I'm not moving to what the mechanism. You understand? I'm only teaching you how to get a product. You understand? They ask here, what will be the product of the reaction when propene reacts with hydrogen chloride or hydrogen bromide? What will be the product? Now understand that hydrogen is always added to the carbon atom with more hydrogen, while chlorine is added to the carbon atom with less hydrogen. What true is this? What true states one is called the Markovnikov addition or rule. Right there. Now they also ask you the exam the rule that states that when adding hydrogen bromide or hydrogen chloride to unsymmetrical alkene, this is called unsymmetrical, 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 unsymmetrical. You understand? Unsymmetrical. Now, the main reason why it's called unsymmetrical is because this carbon atom is having two hydrogen. This one is having what? One hydrogen. So they're not the same. Symmetrical means that they have equal numbers of hydrogen. Unsymmetrical means what? They have equal numbers of hydrogen. So on this unsymmetrical alkene, the rule that states that in the unsymmetrical alkene, hydrogen only added to the carbon atom with what? More hydrogen. While the other group of atom is added to the carbon atom with what? Less hydrogen. It's called what? The Markovnikov rule. Do you understand? So if I do that here, hydrogen will be added here, then chlorine will be added here. So here I have CH3, CH, here we have Cl, here we have CH3. Do you understand? So what is the name? The name is of 2-chloropropane. 2-chloropropane. That is the name. 2 what? Chloro what? Propane. 2 what? Chloropropane. Now, if I have something like this, CH3, CH2, C, here we have CH3, double bond, C, CH3, plus what? HB what? R. What will be the product of this reaction? Let me write this please. What will be the product of this reaction? Before that, these are the 2 points we are focusing on, right? These are the 2 points we are focusing on. This one do not have any hydrogen. This will only have what? One hydrogen. Now, according to mechanical addition, hydrogen is added here. Br what will be added to this point here. Now, for the sake of this body, I'm writing here. So here I'm going to have CH3, CH2. Now here we have C. Here we have CH3 here, right? Now, bromine will be added to this other point here. So here we have B what? R. Then you have CH2, CH3. So what will be the name of the product? So it will be 3 bromo, 3 methyl, 1, 2, 3, 4, 5, pentane. That is what name of the product. 3 bromo, 3 methyl, pentane. Do you understand? Addition of HCl in the presence of what? Peroxide. So in the presence where of what? H2O2, hydrogen peroxide. Now look at something here. Now remember, when hydrogenation undergo reaction, it follow what the mechanical addition, right? Now in some reaction, when you have a peroxide in the presence of hydrogen peroxide. So in the sense that when you have something like CH3, CH, CH2 plus what? HBr. You now have what? A peroxide. Right there, you now what? A peroxide. Now, when you have a peroxide, what will happen here? Anti-Markovnikov rule. Right there will take place. You are using what? Anti-Markovnikov rule. Now, remember, what is Markovnikov rule? Markovnikov will say that hydrogen is likely to come out with more hydrogen. Now, in this anti, the reverse will take place. Hydrogen is likely to come out with what? Less hydrogen. Why the halogen or when halogen we have to come out with what? More hydrogen. It's called the anti. Is the reverse? Is what? The reverse. Do you understand? Remember, we have something like this: CH3, CH, CH2 plus what? HB what? R. What happened here? Here there's no peroxide. This is called Markovnikov rule. So this one hydrogen will be added here, Br will be added here. Follow what Markovnikov rule. Now, but whenever you see in the presence of a peroxide, the inverse will take place. Understand this here, differentiate between two of them. Here there's what? There's a peroxide. Here there is no peroxide. Do you understand? So in presence of peroxide, the anti-Markovnikov rule will take place. Now, instead of hydrogen to be added here, hydrogen will be added here. And there's a reason for that. There's a reason for that, which I'm not going into that reason for now. Understand that whenever you have a peroxide, hydrogen is likely to be covered with what? Less hydrogen. Bromine is likely to be covered with what? Less with more hydrogen. So this is what's going to be the product of the reaction. So you have CH3, CH2, CH2, B what? R. Do you understand? This is called anti-Markovnikov. Anti-Markovnikov. Anti what? Markovnikov rule. Do you understand? Hydrogen is likely to come out with what? Less hydrogen. Bromine is likely to come out with what? More hydrogen. Do you understand? So the name of this one is going to be 1 bromo propane. One what? 1 bromopropane. Now let's look at this other part here. Remember, this one there's no peroxide, so this one will be added here. This one will be added here. So here we have CH3, CH3, here we have Br, here we have CH2. So here we have two different what? Products. Do you understand? So understand when we have a peroxide and when there's no what? Peroxide. There are two different things. You get? Now let's look at another one. Okay, let's look at this compound here. Now, so many students will fail this compound. Now, therefore, you have to what, draw this one in a what? In a carbon chain. This is called skeletal structure. So now let's look at this one here in a carbon chain. They are just like one, two, three, four, five, right? There's a double bond here, and you have CH3. This is that. Now remember, carbon must have how many bonds? Four bonds. This carbon atom is already having four bonds, so no hydrogen will be here. This carbon atom on the other hand is having three bonds, so you have hydrogen. Here we have two hydrogen, two hydrogen, two hydrogen. Here we have two hydrogen, right? So your addition will take place between these 2 points here. So if you're adding HBr to the compound, remember, there is no peroxide, so mechanical flow will take place here, right? So in the mechanical flow, hydrogen is adding the carbon atom with what? With more hydrogen. If you look at this side here, this guy have one hydrogen. This guy does not have any hydrogen at all. And because this one is having one hydrogen added to that one here, hydrogen what to be added here. Bromine what to be added at this point. This is that. So the product is going to be CH3 and what? B what? R. Can you see that? Then we have, do you understand? So I will be added. So you have what? H2. This that. So now the main reason why this hydrogen is added here because it follows what the mechanical flow. Hydrogen is added to the carbon atom with what? With more hydrogen. Then this one we added to what? To this carbon atom with no hydrogen at all. So that's why we have all that one here. So here, this is how it's going to look like. Of course, there won't be there won't be any bond again, right? So you avoid the bond. So here, and now I was CH3. You have BuR. So what will be the product of the reaction? What will be the product of the reaction? So the product of the reaction, let me write this out. The product of the reaction is what? One bromo, one what? Methyl, cyclo what? Pentene, cyclopentene. One bromo, one methyl cyclopentene. That is what product. That is the product. That is what product. Do you understand? That is it. Now, what about if you now have a peroxide? Imagine we have a peroxide. Imagine there's a peroxide here. H2O2. Imagine there's a peroxide here. What happened here? Hydrogen will be added to that one here. Br will be added to that point here. So if there's a peroxide, this is what will happen here. This will be the product of the reaction. So here we have what? CH3. Here we have what? B what? R. Just that when there's a peroxide. Do you understand? Now remember in point of peroxide, hydrogen is actually the carbon atom with less hydrogen. So here we have move here. So move here. You understand? So the name of this product is going to be one bromo, two methyl cyclopentene. That is it. That is what the name of the product. Do you understand? So that is for what? For the hydrogenation. Do you get that? So if you are following this video, please leave at the comment section that you are following and you're getting this very well. So leave at the comment section. So number 4 is what? Hydration. Hydration. So number 4 is what? The number 4 reaction is called hydration. Which is called addition of what? H2, addition of water. So hydration means what? Addition of water. Then you're adding water to what? To the alkene to produce what? Alcohol. Now, but you need an acid catalyst. Do you understand? So hydration, this is the addition of water in the presence of acid catalyst to what? To the alkenes to produce alcohol as a product. Do you get that? So now let me explain to you. So here we have CH2, double bond CH2 plus what? H2O. Now you need one acid catalyst to what? To power the reaction. Idea. Now the main reason why I need the acid catalyst here is because now this guy is a nucleophile and water is also a nucleophile. So you need your acid catalyst to break this one into two. Now remember, like what I told you before, there's a mechanism for this reaction here. But for now, for the sake of this video, now the mechanism is not important here. How to get the product is what most important now. So how do you use this one here? Now this acid we break one into two. We have H plus slash OH what minus. That is H plus slash what OH minus. So what happen here? Now mechanical addition takes place. So now when I say hydration of what of hydration addition of water, it also follows what Markovnikov idea rule. Now, what is Markovnikov rule again? Hydrogen is always added to the carbon atom with more hydrogen, while OH is added to the carbon atom with what less hydrogen. So here, there's no point of what Markovnikov rule because the two carbon atoms are the same. Why? Because they are discussed symmetrical. They have the same numbers of hydrogen atoms. So I can simply what add this one here and add this one here. So I want to have CH3, CH2OH. Here we have ethanol as a product. Ethanol as what? As a product. So what about if you have something like CH3, CH2 plus what? H2O. And we now have H plus. Now this one is what? An acid. Do you understand? Now what happened here? This one here we have H plus slash OH what minus, right? So hydrogen will be added to this point. Why OH will be added to this point? Do you understand? Follow what the mechanical addition. Hydrogen already added to the carbon atom with what more hydrogen. OH is added to the carbon atom with what lesser hydrogen. So the point of the reaction is going to be CH3. Here we have CHOH. Here we have CH3. Can you see that? Now, what is the name of this product here? The name of this product is called 2-propanol. That is the what name of this product. 2-propanol. Hope you understand. So that is it for what? For the hydration of what? Of the alkenes. So please take it down. If you are following, please leave it at the comment section that you are following. If you have any question, also leave it at the comment section that you have a question. If there's any questions, if there's any question related to what I'm doing here that you like to solve, you can also leave it at the comment section. It's very, very important. So what is the next one? What is the next one? We are going to look at the last one in this video. About addition of halogen in the presence of water. In the presence of water. So remember, we have something like CH2 double bond CH2 plus what? BRO2. Then we have water. What will be the product of the reaction? Remember, we have done the one that where only soil is added and where only water is added, right? So now two of them. Now this one, water now acts as the solvent. Now two of them favor react to produce what? Bromine solution. Yes. So therefore, these two will react with each other. This one will not react with one straight. This one will not react with one straight. Two of them will react with each other. So you have BRO2 plus what? H2O. What happened here? Here we have BRO plus HOH. Now look at something here. Bromine solution will be formed. This one will take place of this guy, and this one will take place of this guy. Do you understand? So here we have BROOH. This is that. BRO. Now, which one? Okay. So now, this one, BRO here, this one will move here, and this guy will move here. Now, what happened here? Here we have BH, BROH. BROH. What am I doing safe? So when this occur, now these two therefore reacts. Now when they react, here we have this one here, BRO plus HOH here, right? So this is what will happen here. Substitution reaction will take place. This one will take place the place of this guy to form HB what RO. That is hydrogen bromide. Now when this one come here, what will happen? Here we have hydrogen bromide. Now, where's the place on here? Here we have bromine hydroxide. This is called, now this is what our main point of focus. BROH. Just BROH. Now, you only form bromine solution. Bromine what? Solution. Now, it is the bromine solution that now we added to this point here. Now, if I have something like this, if I have CH2 double bond CH2 plus what? Cl2 H2O. Now what happen here? This one form chlorine solution. This one form ClOH. This is that chlorine what solution? Why this one form what? Bromine solution. Now it is the bromine and chlorine solution that we added here. Do you understand? Now I want you to understand here is that the halogens are always added to the carbon atom with more hydrogen atom. Yes, either bromine or chlorine will be added to the carbon atom with what? More hydrogen atom. So, but here, none of the two carbon atoms are the same. So here we have CH2, here we have BRO, and here we have CH2. The same thing will occur here. Here we have CH2, Cl, here we have C, so here we have CH2, CH3. Do you see that? So here we have bromo. What am I doing? So what is the product of the reaction? Remember, BRO we added here. Here we have OH we added here. So here we have CH2 BRO and here we have CH2OH. Just now, the same thing this one here. Here we have CH2Cl. Here we have CH2OH. So the name of this product is called 2-bromo. 2 what? Bromo. The name of this product is called 2-bromo 1 8 1 what? 8 no. The same thing right here. Here we have 2 chloro 1 no. Now, but now let me restate this here. Now, whenever you add a bromine water to alkene, now the halogens are always added to the carbon atom with more hydrogen atom. Do you understand? So let's take a cool example here. Let me look at another example so I understand this proper. So if I have something like this, CH3, CH2, CH double bond CH2 plus what? BRO2 H2O. Now what happened here? Two of them will react to form a bromine water, right? So you have BROOH. This is the what? This is what you're adding. Just so whenever what a bromine is reacting with what water, to only form what a bromine what solution. Now this B will be added to come out with more hydrogen atoms. So it means that to be added here. OH what to be added here. So you have CH3, CH2, CH. Here we have what B. Here we have what OH. Here we have CH, CH2, B what R. Just so this is what will be the product of the reaction. So what is the name? The name is what? 1-bromo. 2 1 2 3 4 2-butano. That is the product of what? Of the reaction. 1-bromo, 2-butano. Do you understand? So this is just a what? Like a foundation to what? To the reaction. So we are looking at the 5 main type of reaction in which what alkenes undergo. Now, so we are going to end our class here.